CSEC class. We are going to be looking at solving linear equations. This is something that we have done before, a couple times before. And so we're doing it again just for good practice. All right, so what we're going to do, we're going to look at some we're going to look at a number of linear equations with one variable, and we're going to see how to solve those equations. All right, so I'm waiting on my scholars to come in. Okay, so let's go. All right, so when we're solving linear equations with one variable, one unknown, the idea, first of all, is to isolate the variable. So we want to get the variable by itself. And there are a number of ways we can do that. But the basic idea is we want to move everything else to the left, to the right, preferably, and keep the variable on the left if we can. All right, so 53 plus W is equal to 106. So we're asking ourselves, 53 plus what number? So remember, W is representing the unknown here. 53 plus which number would give 106? We already have the variable on the left. So we need to move the 53 then to the right. And since it's a positive 53, when we're moving it to the right, it's going to become negative, because we have to do the opposite operation. So when we're moving the number or the term, we do the opposite of what we originally had. So since it was a positive 53, now when we move it to the right, it's going to be a negative 53. So we're going to have W is equal to 106 minus 53 is 53. So W, if we substitute this value back here, 53 plus 53 is 106. So that's how we know we are correct. Suppose we had P minus 92 would give 5. So which number you take 92 from it, you would end up with 5. So we have the P on the left. We want to move the 92, the negative 92 to the right-hand side. It's going to become a positive 92. So we're going to have P is equal to 5 plus 92. Because remember, once you're going to take the number and the sign goes with the number that follows it. So it's a negative 92. You're taking that and moving it to the right. It's going to become a positive 92. So P will be equal to 5 plus 92 is 97. How about if we have negative x minus 6 is equal to 14? We have the variable on the left, but it's negative, and we don't want a negative variable. We could leave it. We could leave it and make it stay negative, and then bring across the negative 6 to the right. So that is going to become positive 6. So we would have negative x is equal to 20. But we don't want a negative x, we want x. So to get rid of the negative sign, we're going to divide both sides by -1. So negative x divided by -1 would now give a positive x. And 20 divided by -1 will give a negative 20. We could also have done it this way. So we could have said, all right, I don't want a negative x. So instead of moving the negative 6, let me move the negative x to the right. So I would have negative 6 is equal to 14. And now I would have my plus x. But then I need x by itself. I need to isolate it. So I'm going to bring the 14 over here. So I would have negative 6 minus 14. Still have my positive x. This would give negative 20. And then all I'd have to do now is to rewrite it with the x over the left and the negative 20 over the right. I'm not changing anything. I'm just kind of twisting around the equation. I like to think of it as, right? All right. So give me some feedback. All right. So I'm getting some answers here. So Sajarta gave the correct answer for the first equation, 53. And I'm seeing John is saying 97 is the answer for the second one. Remember, when you're posting your answers, please put, well, I know I don't number these ones. I should start numbering them. So when you're posting your answers, I can see exactly which number you're answering. All right. Yeah. So Ngozi is saying it looks pretty straightforward, and it is. As with everything in math, it boils down to practice. All right. It boils down to practice. So a student is asking me not to skip the screen as yet. He wants to jot down quickly those equations. All right. So yeah, it's pretty straightforward. Isolate the variable. Whatever you do on one side, you do the same on the other side. You can think of it that way as well. I prefer to just say, okay, I'm going to move something to the other side. In order to isolate the variable, I have to move everything else to the other side. And when I'm doing that, once it's going to go across the equal sign, the sign is going to change or the operation is going to change. If it was plus, it's going to become negative. If it was minus, it's going to become positive when I move it. If I was dividing by it, I need to multiply by it. If I was multiplying, I need to divide. So it's like you're saying you have to do the opposite operation. Can I go ahead now and change the slide? All right, so John is asking, how did I get the negative 20? Well, negative 6 minus 14. That's how I got the negative 20. negative 6 minus 14. Or for the first one, where I have the negative 20, because I had a negative x equals 20, and I don't want a negative x, I want a positive x. So I divided both sides by negative 1, which automatically changed the negative x to a positive x, and changed the 20 to a negative 20. All right, so Linda, welcome. Linda is saying accurate and simple method. Yes, everyone is agreeing. These are very simple steps. What we're going to do now, we're still on solving linear. We're going to just make it a little bit more complex, not difficult, but complex, in that there are other steps you need to follow. So let's say you were given 2x plus 9 is equal to 5x. So that's still a linear equation. It still has one variable. The variable is x. It's just x. There are two x's, but it's the same variable, right? They are like terms. And we have a bracket here. So we're going to need to expand the bracket first using the distributive law. And then we're going to need to group the like terms. So just a few more steps, but they are not difficult steps, right? They are not difficult steps, but it's more steps. So let's expand the bracket first. So we know that whenever we have brackets, the term that is immediately in front of the bracket, once it's not separated from the bracket by a plus sign or a minus sign, we are going to multiply each term in the bracket by this term on the outside. So that means 2 times x, which is 2x, and 2 times positive 9, which is positive 18, is equal to 5x. So now we need to group our like terms. The 2x and the 5x, we can combine them. So I'm going to leave my 18, and we try to work with our variables on the left. But in this case, if I brought over the 5x, it would be a negative 5x, which would give me a negative variable, which I don't want. So sometimes you have to look for, other ways. So I'm going to leave my 5x and bring across the 2x. And the 2x is going to become negative now because it was positive over here. So 18 is equal to 3x. So now I'm multiplying the 3 and the x. So to get rid of the 3, I need to divide by 3. So it will be 18 divided by 3. So x is 6. And then I can just rewrite it, putting the x on the left. So 6 equals x equals 6. Right? And we can plug that back in. Whenever you solve equations in algebra and you get the value of your variable, plug that variable, substitute it back into the original equation. So if we're saying that x is 6, if we put it back up here wherever x is, so 5, 6 is 30. 6 plus 9 is 15, and 2 times 15 gives 30. So we know that we are correct. We got 30 on each side. Let's do one that involves negative. So negative 5x minus 4 is equal to 10x. All right. So we know that we need to expand our bracket using the distributive law. And the distributive law says whatever is immediately in front of the bracket, we are to use that term to multiply each term inside the bracket. So it will be negative 5 times x, which is negative 5x. Negative 5 times negative 4, now that gives a positive 20. Remember, negative times negative is positive. And then we have our 10x. All right, so again, I'm looking, because you see, at every step, you have to kind of step forward and look at the bigger picture. Look at the bigger picture. It's like you're a soldier on the field, and you have to be assessing the situation to see the best move to make. Because it's all up to you, you have to manipulate the equations. You can do this, you can do that. What thing is the best thing to do here? So even though we say it's better to keep the variable on the left, I'm looking ahead and I'm saying, all right, but if I bring across the 10x, it's gonna become negative. I'm gonna have a negative variable, which is not a big problem because I can just divide it by -1 to get my final answer to make it positive. But I just prefer to work with positive variables. That's just my thing. So what I'm gonna do is I'm gonna leave the 20 over on the left, and I'm gonna bring across the minus 5x, and now it's going to become plus 5x. So what I have is 20 is equal to 15x. All right, so to get rid of the 15 from the x, to break that attachment, they are multiplying each other here. We need to divide by 15. So 20 divided by 15. And that would give 1 and 5 over 20, which is 1/3. Sorry, not 1/3. That would be a quarter. All right, so 5 over 20. So 5 is left back. Oh, it's not 5 over 20. 15 into 20, 1 times remainder, 5 over 15. So it is 1/3. So I was right. All right, so now I just need to switch that round, and I'll have 1 and 1/3. And again, even though it's a fraction, we would be able to plug that in. It's easier, I think it will be easier to plug it in this form before we change it to that, right? So negative 15 times 20. So let's work it here. So if we plug in this value for x back here, so it will be negative 5 times 20 over, my mouse seizing up, negative 5 times 20 over 15, and negative 5 times negative 4. All right, so 5 into 5, 1, 5 into 15, 3. So that would be negative 20 over 3. And negative 5 times negative 4, that's a positive 20. And 10 times 20 over 15. Okay, so 5 into that, 2, 5 into that 3. So that's 40 over 3. All right, so the 40 over 3, that gives what? 13 and 1/3. All right, so over here we have negative 20 divided by 3. So that's negative 6 and 2/3 plus the 20. And that gives 13 and 1/3. So this gives 13 and 1/3, and this part of it, the 10x, gives 13 and 1/3. So this is just checking to make sure that when we plug in back the answer, we get the same thing on both sides. All right, so occasionally I have to check my chat to see what's happening. Okay, so John is asking how I got the 1/3. So I'm assuming it's for the second problem. So we had 20 over 15. So 20 divided by 15, that's 1. 1 time, remainder 5 over 15. And the 5 over 15 gives 1/3. The first one, which first one? Which first 1/3, John? All right, so Ngozi, would you want me to go over that one? You're saying it's a lot to take in? Your last comment was that it looks pretty straightforward, and now you're saying it's a lot to take in. So would you like me to go over it? The last one? Or the two last ones? So John is saying the 10x. The 10x didn't give 1/3, John. This 10x was part of the original equation. So let me take it. Let me go back from this one. So I think some persons are seeing the brackets and getting scared. But it's the same concept, right? All we're doing is to expand the brackets first. That's all we're doing. And then we're back to the original thing, grouping the like terms, isolating the variable. It's just about 2 additional steps, right? Expanding the bracket, grouping the like terms. So don't get scared. It's the same thing. The same thing that you were saying is straightforward and easy. We just put in 2 more steps in it. So let's look back at the first equation where we had the brackets, where we introduced the bracket. So we had 2 bracket, x plus 9 bracket is equal to 5x. So we're going to use the distributive law to expand the bracket. So we have 2 times x is 2x. 2 times 9 is 18. And now we want to get the x's on one side and the whole numbers on one side. I decided to bring across the 2x over here because I could have brought across the 5x and I would get 2x minus 5x, which would give me a negative 3x. I prefer not to work with negative variables. You can work with them, and then in the final analysis, you can divide them by -1 to make them positive. So it's all up to you, you know. It's up to you. I prefer to work with positive variables. So I decided to move the 2x from the left to the right, and it's going to become a minus 2x. So the 18 remained on the left. So the 5x minus 2x, that gives 3x. And then to isolate the x by itself, I'm going to need to divide the 18 by 3. So 18 divided by 3 is 6. And just that this is the presentable way to write it. So you're not wrong if you say 6 is equal to x. It means the same thing as x is equal to 6. Just that this is the preferred way to write your final answer with the variable on the left-hand side. So for this equation now, again, we had brackets that we needed to expand using the distributive law. So -5 times x, that gives -5x. -5 times -4 gives +20. And I decided to move the -5x to the right so that it became a +5x, and add it to the 10x, and I got 15x. So now I need to divide by 15 so I can get rid of the 15 on the right and leave the x. So I have to divide the 20 by 15, which is 1 1/3. And that is going to give me the answer. All right, so excuse me for 1 second. All right, so x is 1 1/3. So this part now is not a part of the solution. This is actually checking if your answer is correct, right? So this is something you would do just on rough paper, just for your own satisfaction, to make sure that what you did is correct. So we're plugging in the value of x here and here to see if they are equal to each other. And I was saying it's easier to use the 20 over 15 than the 1 1/3, because you're still going to have to change this back to an improper fraction anyway to multiply it by that, right? So I just plugged in the 20 over 15 here and multiply it by 10 also. And in both cases, I got 13 1/3. So we know that the answer is correct. So we're going to do 2 more. Let's do 2 more. And then we can wrap that up for the solving linear equations. All right, let's use another variable than x or y, just to let you know that it can be any letter. So 3w plus 8 minus 5w is equal to 4w minus 1. Let's even add something else. I'm just showing you that they can come as long as possible. Don't be scared, just contract them. If you have brackets, expand out the brackets and then simplify, put all your like terms together. And you'll see that you end up back with a plain and simple linear equation to solve. So don't be scared by this long, winding road of variables and numbers and whatever. Don't make that scare you. So let's expand first. So we're right back. So we can simplify on the left. We can simplify the -3w minus 5w. That's gonna give minus 8w. Right? We can simplify that. Plus 8. On the right-hand side, let's expand the brackets. So 4 times W is 4W. 4 times -1 is -4 plus 5. And we can simplify the -4 plus 5. So we have 8W, -8W plus 8 is equal to 4W. And the -4 plus 5 is +1. So you see how it's looking even simpler now? All right, so we have a -8W. All right, let's leave it on the left. So -8W, we're going to bring across the 4W is going to become a -4W. And the 1 remains on the right, and we're going to move the 8 to the right, is going to become minus. Okay. So what we have here, -8W minus 4W is -12W. And 1 minus 8 is -7. So I need W by itself. So I'm going to divide by -12 to cancel out that 12. And I have to divide the -7 also by -12. And negative divided by negative is positive. So we're left with 7/12 as our answer. All right, let's do one more for the road. Let's do one more for the road. All right, so let's say we have 3B minus 6. You know, I shouldn't use a B because I don't want you to confuse it for a 6. All right, so let's use C. So C minus 6. Okay, plus 7. C plus 8 minus 5 is equal to C. 3C minus 15. All right. It looks long and winding, but it's really simple. It just looks hard, but it's simple. So we just need to expand the brackets first. So 3 times C is 3C. 3 times -6 is -18. 7 times C is positive 7C. 7 times 8 is 56. And we have 3C minus 15. So what can we group on the left? We can group our C's together. So we have 3C plus 7C. That's 10C. -18 plus 56. -18 plus 56 minus 5. All right, so that gives a positive 33. All right, so you see how simple it's looking now. We're simplifying it. So now we can group our C's and group our whole numbers. So we have 10C. Bring over the 3C, is going to become minus 3C. And we had our -15 on the right. And we bring over this 33, it's going to become minus 33. So 10C minus 3C is 7C. -15 minus 33 is -48. So C would be -48 divided by 7. And that would be negative 6 and 6/7. And that's it. That is it. All right. So give me some feedback. How you find okay, so Carissa, you're saying that this last one here looks confusing. The one in the red that's on the screen now, or the one before that you were talking? The one in the red you want me to go over? John is saying 20/15 is 1 and 1/5. 15 into 20 goes 1 time, remainder 5/15. 5 into 5, 1, and 5 into 15, 3. All right, so Carissa, you were talking about the black, that one in the black. That's the one you want me to go over? All right, so let me, but I don't know which one then. I'm not sure which one you want me to go over then. All right, but what you can do, I'm going to go over the last two. And then what you can do is just, when you get the time, just go over just watch over the video. The one before this, that one. I wonder if it's because I have the working out beside it. It looks, is it because I have the check? I was checking the answer. It looked confusing to, remember, you wouldn't need to include this as the answer, you know. This is just checking. That's just checking. So let me go over this. So what we did is we're expanding the brackets. So sorry, we grouped the negative 3W minus 5W, that give us negative 8W. And when we expand this bracket on the right, 4 times W is 4W, 4 times negative 1 is negative 4. And we group the negative 4 plus 1 to get 5. So this is the simplified version of it. We expanded the brackets, grouped the W's, and now this is what we're left with. So now we just bring over the 4W, it becomes minus 4W. So negative 8W minus 4W, that's negative 12W. And we brought over the 8 to be with the 1, it's going to become a minus 8 because it was positive on the left. So that's negative 7. And negative divided by negative is positive. And for that one, again, we expand the brackets. 3 times C, 3 times negative 6, 7 times C, 7 times 8. And then we group all the C's. So 3C plus 7C is 10C. And then we bring over this 3C here and take it away. From the 10C, we get back the 7C. Grouping the whole numbers, we had a minus 15. And we carry over the 33, become a minus 33. And these two give negative 48. So now to isolate the variable, to get the C by itself, we divide by 7 on both sides. And this is our answer. Remember, these videos are there always, so you can go and watch it again. And Gozi says sending her in circles. Well, you can go in circles, keep going in circles until you hear a voice say stop. And at that time, you will understand it. All right, and you can keep watching the videos, go to the playlist, or just go on the channel, search for the video and watch it again and again. And you can always leave comments under the video, and I'll answer those comments as well. So even if this live video has closed off, I will come back and answer the questions. Okay. All right. So that's it for solving linear equations.